Hello, this is my final presentation for this class. In my benchmark paper last week, I chose zinc as my element. Zinc is a pretty interesting element, has a lot of data on it, and it's a transition metal that has some pretty cool properties, so I'll get into some of that in just a little bit. But mainly I'm going to be talking about the existence, reactivity, and the application of zinc. This type of slideshow could be something I show to my AP chemistry students, or I can show them this slideshow as an example, as a project for them to do and assign them an element or a topic, and for them to basically make a presentation, video or PowerPoint or whatever, similar to what I'm doing today. So this can be used as an example for them, or this can be used as a lecture. So the objectives today, I'm going to be talking about the existence of zinc, and I'll get into the history, its occurrence in nature, and how it can be extracted. I'll talk about their reactivity and get into some of the physical and chemical properties as well as bonding. I will talk about the application of zinc, how it's used today, and any toxicological effects that it may have. And finally, I will talk about a paper that I read about zinc oxide and icthamol, and how that relates to wound care. That's what we'll get into today. So it's really important to study zinc and any other transition metals because we're constantly coming up with new medicines and new medicinal uses and treatments. Zinc is one of those that is used for medicines and vitamins and all kinds of stuff. Also, it's used in cosmetics, it's used in technology, it's used for buildings and trades and all types of things. It's also really important to teach concepts like transition metal properties and bonding and other characteristics in AP chemistry, or even in like entry-level college chemistry classes, because sometimes transition metals are kind of skipped over in regular chemistry classes in high school. So most students don't know a whole lot about these elements on the periodic table. The focus in normal regular chemistry is never on transition metals. So this is a great project or a great objective to teach to those students. So first we're talking about the existence of zinc. I will talk about the history, occurrence in nature, and the extraction. The history of zinc, it's really interesting. There's evidence that it was used in Roman times, although they may have not had like a specific name for it. Zinc ores were used to make brass during 1400 to 1000 BC. There was also zinc refining in China in the 1500s. If you were to Google when zinc was discovered, it would probably say either 1668 or it would say 1746. In 1668, there was a Flemish metallurgist, and he extracted zinc from zinc oxide. In Europe, though, zinc wasn't discovered until 1746, and that was by a German chemist. So really, the main official discovery and the official name of zinc was in 1746. In nature, zinc is found all over the place. It's found in Earth's crust, it's found in the atmosphere, it's found in bodies of water. It's actually more abundant than copper in the environment. So for every 65 grams of zinc, that's going to be in every ton of Earth's crust. And it's kind of a lot for a mineral that's so small. It can also be transported through natural cycles like the water cycle or the rock cycle or anything like that. So what happens is there could be some sediments or some rocks that contain zinc. That zinc can be transported to other bodies of water through eroding or just rainwater or anything like that. From there, it can kind of evaporate if it's small enough and go through the whole water cycle again, or it could be eaten or metabolized by different organisms and kind of go through that whole cycle. To extract zinc, it has to be mined or extracted underground. It has to be heated to 950 Celsius to oxidize, and then the powder form is going to be rinsed with sulfuric acid and then neutralized to kind of purify it and use it for whatever it needs to be used for after all the contaminants are removed. It's actually a relatively cheap process, so zinc is used in a lot more things as an alternative or as a cheaper option. The reactivity of zinc. So we're going to talk about physical and chemical properties and bonding. So zinc on your periodic table is just Zn. The number of protons is 30, and then it has a mass of about 65. It's insoluble in water, but it is soluble in acids and alkalis. It's usually malleable, which means we can bend it and kind of shape it, but it will become brittle and easily break apart at 210 Celsius. The boiling point is 907 Celsius. The melting point is 419 Celsius. Zinc is going to be stable in dry air, but it can oxidize in humidity or moist environments, and that will give it kind of a white carbonate coating on it. Zinc's also a good conductor. The structure is kind of a hexagonal crystal type structure, and zinc has the +2 oxidation state. That means it's willing to give up two of its valence electrons to help form bonds. It's also noted that there's 5 stable isotopes of zinc. We have zinc 64, 66, 67, 68, and 70. Those are going to be the most common types of zinc that you're going to find. For bonding of zinc, we have a few common compounds. We have zinc carbides, zinc halogenides, zinc phosphide, zinc oxides, which I'm going to go into a lot more detail about, and also zinc hydroxides. That +2 charge is just telling us that zinc can easily donate 2 valence electrons, and that's how it's going to form a lot of those bonds. Generally, because zinc is a metal, it's going to form ionic bonds with other elements, or if we're talking about zinc to zinc bonding, that's just a metallic bond where those valence electrons are kind of just floating around in a sea of electrons. Very, very rarely you will see the +1 oxidation state, but that's really not common at all. Next, we have the application of zinc, how it's used, and if there's any toxicological effects. So main uses of zinc are going to be for galvanizing metals. This just prevents rusting. Zinc's also used in coins. So even things like pennies, until I want to say in the 60s, pennies were made of complete copper, but prices of that kind of went up, and so then pennies weren't even worth the 1 cent that they were representing. So nowadays, pennies are mostly zinc with a little bit of copper coating, and that's just to save cost. Zinc oxides can be used for paints, rubber, cosmetics, pharmaceuticals like diaper rash ointment is one of the main ones, plastics, ink, soap, batteries, electrical equipment, and even some textiles. Zinc sulfide can be used for paints, fluorescent lights, and even x-ray screens. And then, of course, zinc is one of our micromolecules that we need to survive and we need in our body. So biological processes like forming active sites on enzymes, stabilizing DNA, gene expression, and immune function, all of those things need zinc to work correctly. It's also noted that the cost of zinc is about $1.3 per pound, so it's really inexpensive, especially when we're using it to galvanize metals for things like cars and large transportation equipment and street posts and bridges and all kinds of things. For toxicological effects, there's really not a whole lot for just zinc by itself. Generally, with vitamins and types of things that we need in our body, if there's any extra left over, it's just released through waste. So if we have extra zinc in the body, it's just going to go to our waste. Zinc oxide in large amounts can lead to metal poisoning, and the symptoms of that would be fever, cough, diarrhea, mouth irritation, stomach pain, and a few more things. Also, zinc oxide, if it's in the gas form, the fumes could lead to metal fume fever, which is pretty serious, but generally if you get away from the fumes, those symptoms start to go away. Now I would like to talk about a paper that I read about zinc oxide and icthamol. wound care is one of the main things that zinc oxide is used for. It's also one of the active ingredients in diaper rash cream. It's just really, really good for wound care. So this paper that is linked here, it studies the use of zinc oxide ointment for wounds. They mostly talked about wounds on lower extremities like your legs. They studied it both by itself and with ichthamol mixed in. Zinc oxide is going to be important for wound care because sometimes you have elderly patients and patients with malnutrition needs that don't get enough zinc in their diet, and so they start having deficiencies, which leads to delayed healing on some of those wounds that they very easily get. So topical zinc increase the levels of zinc in the epidermis and the interstitial fluids and the dermis, and it decreased the amount of healing time. So they saw through these studies that taking vitamins wasn't really improving the healing rate. So zinc in their, even though they were getting extra zinc in their diet through vitamins, it was much, much faster healing rates when they applied zinc oxide directly to the wounds, and it was absorbed through the skin that way to help increase the rate that it would heal. There was also some evidence that when it was mixed with this ichthamol, which is shale oil, it improved blood flow and even sometimes acted as an antibacterial. So very interesting, something that is definitely beneficial and probably should be studied a little bit more and see what else we can use zinc oxide for, wound-wise or just in the medical field. So I have all my references here for you if you would like to check those out. That's it for today. Again, this would be a great project to use in AP chemistry and give them zinc as an example and then assign them different elements on the periodic table, mainly specifically transition metals, and have them come up with their own presentation or their own project. All right, thank you. Bye-bye.